Hello everyone. Alright, so let's proceed our next example. I'm going to demonstrate to you example on the boundary conditions. So first look at your textbooks, page 209, exercise 5.9. So in this case, you are given homogeneous dielectric with relative permittivity of 2.5, which is filled in the first region down here. And also the other region up here is a free space, all right, with s r equal to 1. We know that. So now since we are given the d1, right, the d1 vector given as 12 x component minus 10 y component plus 4z component nanocoulomb per meter squared. So now we are given the D1 field, and now we are going to find the D2 field. Right guys, so let's recall our last lecture. Actually the D2T is composed of two main components, which are the first one, the D2 normal component plus D2 tangential component. So the same thing goes to the D1 field. We have D1 normal component and also the D1 tangential component. Alright, so as usual, if you want to solve any boundary condition problem, we have to relate to these two famous equations that can be usually used to find the normal and tangential component. Okay, the first one here, we know that the first equation given as the D2 normal minus D1 normal equal to the rho s. Alright, so this equation guys can be derived from our first Maxwell equations, the first equation, and then the other one here we can have E1 tangentials is equal to the E2 tangential, and this is your second equations. Alright, so the first one here you can find, so since we don't have any charge given in the equation, so we can simply actually assume that there is no surface charge appear on the boundary. So from here, from number 1, we can have the D2 normal is equal to D1 normal. So if you see from the D1 equation here, so since our interface or the boundary located exactly along the x equal to 0, so automatically we know that this term or the first component here actually belongs to D1 normal component, and then the rest of it actually belongs to the D1 tangential component. So from here we know that D2n will be equal to the D1n will be equal to the 12x component. Alright, good. 12x component. Now done. So now we are going to find the other part of it. We have to find the D2 tangential component. So again, this one can be obtained using the second equation over here. So from number 2, just convert this E into the D term. Now we have D1 tangential over epsilon 1 is equal to D2 tangentials over epsilon number 2. And then now we are going to find the D2 tangential. So we know that also guys, this epsilon 1 is equal to the epsilon naught epsilon r1, and then this epsilon 2 equal to the epsilon naught epsilon r number 2. So rearrange the equation, you can find the D2 tangentials is equal to the epsilon r2 over epsilon r1 D1 tangential. So we know that guys, this is equal to 1, and then this is equal to 2.5, isn't it? Okay, let's proceed to the next part of it. So finally we can find the D2 tangential component. 1 over 2.5 negative 10 y component plus 4z component, and finally gonna have this equation negative 4y component plus 1.6 z component, and for sure have unit of nanocoulomb per meter squared. So now let's combine them to find the D2 as shown here. You need to combine between normal and tangential component. So this is your tangential component, this is your normal component, this is your tangential component. So let's combine them to find the D2 vector is equal to 12x component minus 4y component plus 1.6 z component nanocoulomb per meter squared. Alright, so done for that. So now we are going to find the theta 2, the angle that measured from the D2 vector line with respect to the normal line over here. So the theta 2 can be simply obtained using this approach, arctangent, which is this line over this line. Alright, so the first one over here is your tangential component of the magnitude. So take it the D2 tangential, but only taking the magnitude over the D2 normal. Again, just take the magnitude. Alright, so from here you can proceed and you can find the value as given in the textbooks. So bear in mind guys, this 2n component actually equal to 12, and then this tangential components is obtained from these tangential equations, whereby you're gonna have minus 4 squared plus 1.6 squared square root. Right, so if you proceed, you can see the value of the angle is equal to approximately 9.75 degree. Right guys, so I hope you can try yourself, and all the best. Thank you.